Okay, in this video, I'm just going to give a very quick overview of statistics. Obviously, statistics is a much broader, covers a much broader spectrum than what we're going to look at. But we're just going to look at kind of some elementary concepts. So, the first thing we're going to talk about is that the definition of statistics is simply just the collection, evaluation, and interpretation of data. And data, again, could mean a wide range of things. So we have what are called descriptive statistics and inferential statistics. So descriptive is we collect some data and then we just describe what's going on with that. Inferential is we look at a sample of data. Okay, so however many people or things we take data points of, we then use that to generalize something about a greater population. We have qualitative data versus quantitative data. So qualitative, you just talk about qualities of something. There are no numbers involved here. Things like colors of M&Ms, breeds of dogs, anything that does not involve a number that you can make different comparisons of would be qualitative data. Quantitative data deals with numbers. How many people in a population, the number of M&Ms, the number of defective parts, and so forth. It all deals with numbers. We have actual numbers to deal with there. So data collection can be done in a lot of different ways. We're not going to get into a bunch of these, but if you do take a statistics class, you will talk about all these different ways that you can collect data. And then when you represent data, you can do so in a number of ways. You can make a histogram. So another way of describing that is a frequency distribution graph. You can make kind of like what you would consider maybe to be a line graph of that information. You can make a bar chart or bar graph and a pie graph. Okay, so I think you've probably seen all those before, but there are lots of different ways to represent data. We're going to focus on histograms primarily, but hopefully none of those are foreign. So the most elementary concept of statistics is measures of central tendency. So this is something that hopefully you've seen before. The first of those central tendency measures is called the mean, and the mean is simply just the average. So when we calculate the mean, what this formula is saying is add up all of the values and divide by however many there are. So n is the number of data points. X is what are those data points. Add all those up, divide by how many there are, and that gives you the average or the mean. It is the most frequently used measure of central tendency. However, hopefully you remember from your discussion of this, whether that be in junior high or whenever that was, hopefully you remember that sometimes the mean can get skewed a little bit if there are outliers, right? So if we have something that is really far away from the majority of our data set, our mean could be skewed by that. Okay, so here we have a data set. We just want to calculate the mean of this. So an example of that just shows adding up all of those numbers, and then there are 11 pieces of data there. There are 11 numbers there, so I take the sum of all those and divide by 11, and that gives me an average of 47.64. Let me go back real quick, and I may talk about this later on, but hopefully you notice there are a couple outliers here. Most of these numbers are pretty close in value, but then we have 2 and 5. And so if you look at our average number, 47.64, and you look at the data that's actually in here, perhaps you consider maybe that this isn't the best measure of central tendency here, because this 47.64 is lower than most of the numbers, with the exception of just those 2 outliers of 2 and 5. The median is you write the numbers in order and you look for the middle number. If you have an even set of numbers, and you do the average of the 2 middle ones. It is useful in situations when you do have outliers, because those are not going to skew the data so much. So if I want to find the median value of this, the first thing I would do is put it in numerical order, and then I would look for what is the middle number of this data set. Okay, which would be 58. Again, if it had an even number of values, so this is just the same thing except throwing out the 2, which would give us an even set here, what we would do is take the two middle values and average those, 58 and 59, and average those, and you would get a median of 58.5. And then the mode is the most frequently occurring response. Typically, it's not going to be the best measure of central tendency, but you can use it. Again, it may not exist at all. You may not have any data points that are the same. You could have multiple ones that are the same. So we could have something that's called bimodal, which means there are possibly two modes where both of those are occurring the most often. So here we have the number 63 occurring twice. So the mode of this data set is 63. Here's another data set. If I want to find the mode of this, I have both 63 and 59 occurring more than once. So this is bimodal. 63 and 59 are both considered the mode of the data. And then here's an example where there are three of them. So instead of bimodal, we could say trimodal or multimodal. Okay, data variation. So how is our data spread out, right? How is it scattered out? So we can figure out what's called the range, which is something you've probably done before, where you just take the highest value and subtract the lowest value of your data set, and that would give you the range of your data set. We can also find something called standard deviation, which is a bit of a long process, but standard deviation is used a ton in statistics. And so it tells you the standard deviation is the square root of the variance. Well, what is the variance? We'll talk about that as we go on through here. So again, the range is just the highest number minus the lowest number. So if I have a data set, this is in order numerical value from lowest to biggest. The range is going to be 63 minus 2. Just subtract the smallest number from the biggest number. The range is 61. Okay, then we jump into standard deviation. There's a slight difference between sample standard deviation and population standard deviation. Okay, and so if you want to determine the difference here, you can pause the video at this point and read that. I'm not going to go through that. We are going to use sample standard deviation when we calculate our standard deviations. Okay, so we've got a lot of different variables here. The formula looks kind of ugly. We need to figure out what exactly it is that we're trying to do here. So the x bar is the mean of the data set. Okay, so hopefully you can find that. Find the average of the data set. So the process of finding standard deviation is to take every single value in your data set and subtract the mean from it, and then square that number, and then add all of those up. That's what this says, right? This epsilon says to add all of those things up. So if I take every single number in the data set and subtract the mean and square it, and then I add all of those together, then I'm going to divide by how many we have, how many data points we have, minus 1, and then I'm going to take the square root of that. Okay, so there's a lot of steps there. So when you do standard deviation, I would strongly encourage you to do each step, be very calculated about when you do each step so that you don't lose track of things and you don't try to do too many steps at once. So we're going to go ahead and look at how to calculate the standard deviation of this data set. Again, this is going to take a while, but I am going to ask you guys to do this and so that you understand how to find standard deviation. So the first thing I need to do is find the mean of the data. So I'm going to add all these up, divide by 11. We already figured this out. It was 47.64. That is the mean of the data. Then what we're going to do is, and I would maybe split this up into a couple different steps, and here they're doing it all at once. I'm going to take the mean and subtract it from every single one of these numbers. Okay, I would maybe do that as a separate step. Just take each number minus the mean. What we're doing here, we're doing a couple steps at once. We're doing that, but then we are also squaring that number. So 2 minus 47.64, square it. And we're going to do 5 minus 47.64 and square it. And we're going to do that with every single number in our data set. Okay, and we're going to get all these values here. Oops, let me go back. We're going to get all these values from when we subtract the mean from the numbers and square them. And notice how those numbers range in value. There's quite a bit of a difference in what values you get when you do that. Okay, so we do that. The next thing is to add all those together. So they're using S. I would use the epsilon here, which is saying add all those things together. So all the values that you just got from the last step, we're going to add all those together. And that gives us this number of 5,024.55. The next thing we do, so that's the numerator of this fraction. That's what we just found. We're going to divide by n minus 1. Well, n is the number of data points, which is 11. We're going to subtract 1 from that, which would give us 10. And we're going to take 5,024.55 and divide by 10, which gives us 502.46 when rounded. The very last step is to then take the square root of that. So this is considered to be the variance, this 502.46. That's what's called the variance. If we take the square root of that, we then have the standard deviation. So if I take the square root of 502.46, we get 22.42. Now, we're just finding standard deviation. I'm not really going to get into what the standard deviation tells you about the data set a ton. Okay, we'll talk about briefly. But in statistics, this is a really important number, and it tells you a lot about looking at sets of data. Okay, so I'm going to skip through this. This is calculating the population standard deviation. It's going to be a similar number to what we just got, but I'm going to skip through this part. Just notice it's a very similar number. It's pretty much the same idea. There's just a couple of differences there. Okay, so next we'll get into how to represent your data using how to graph your data. And so what we're going to do is look at if a coin is tossed 3 times, we're going to assign the variable x to represent the frequency of heads occurring each toss. So notice we have, these are the different outcomes you can have if you toss a coin 3 times. Those are all the different outcomes that could happen. X is the number of times that we get heads. So if you go through there, that is how many times you get heads for each one of those outcomes. So the question is, when is x 1? Well, that's when heads only occurs once, so that would be your first toss, your second toss, or your third toss being heads, and the other 2 being tails. The calculated likelihood that an outcome, a variable, will occur. So this is how many times we get heads, right? So 0, there's 1 in 8 chance that we get 0 heads, and that's all of them being tails. If x is 1, that means there was exactly 1 heads that occurred on 3 coin flips. That happened 3 out of 8 times. 2 also happened 3 out of 8 times. And 3 would only happen 1 in 8, which again is if we get all heads, right? So this is a table that helps us represent our frequency in how many times we get heads on a coin flip 3 times. And then we can make a histogram out of this. So what we're seeing here is that if x represents the number of times that you get heads on 3 coin flips, this shows us there's a 1 in 8 chance that you get 0. There is a 3 in 8 chance that you get either 1 or 2 individually. Sorry, a 3 in 8 chance that you get 1, and a 3 in 8 chance that you get 2. And then there's a 1 in 8 chance that you get 3. Okay, so here's a more detailed histogram talking about airplane passenger seats available in terms of how many open seats there are and how close we are to the departure of that plane. Okay, so again, a brief discussion on statistics. Hopefully, if anything is confusing, you can go back and pause the video and look at that again. But the main point there is that you're able to do measures of central tendency and that you can find standard deviation.